A very good afternoon, ladies and gentlemen.
Welcome to the TP Engineering Tech Show 2022. I am Alicia and I am from the Diploma in Aviation Management.
I am Nadira. I'm from the Diploma in Architectural Technology and Building Services. And it's our pleasure to be your MCs for today's program.
For more than 20 years, the School of Engineering have hosted industry guests, parents, students, and members of the public on campus at their annual engineering project show.
This year, in order to reach out to all of you, we have taken up the challenge of hosting an online tech show. And we hope you enjoy the safety and convenience of our streamed virtual online format.
The Director of School of Engineering, Temasek Polytechnic, members of the School Advisory Committee, our industry guests and partners, Mr. Danny Tan and Ms. Danny Lau from NEC Asia Pacific Private Limited, distinguished guests, parents and students, ladies and gentlemen, we are extremely delighted to have you here with us today.
Without further ado, we are pleased to introduce the Director of the School of Engineering, Temasek Polytechnic, Mr. Song Kwok Yuan, who will give the opening address. Mr. Song, please.
Good afternoon, one and all, and thank you for taking the time to join us at our TP Engineering Technology Show 2022. We are honored that joining us virtually at our show today are members of our School Advisory Committee, our partners from the industry, teachers and students from secondary schools and Institute of Higher Learning, as well as our colleagues and students from Temasek Polytechnic. At today's show, you will be able to view innovative projects across 4 thematic areas, namely aviation and aerospace, sustainable built environment, healthcare, as well as industrial automation and digitalization. These innovations are the final year projects that our students had worked on over the past year, and many of them have been developed in close collaboration with our industry partners. The projects are the results of not just the hard work that our students and the supervisors have put in, but it is also evidence of our strong industry links and our good working relationship with our partners. With Industry 4.0 in full swing today, new technologies such as smart automation, artificial intelligence, machine learning, the Internet of Things, as well as virtual reality, augmented reality, and even 3D printing, just to name a few, have never been more important than they are today. Hence, it is vital for us to keep abreast of these new technologies. Otherwise, we can easily be overtaken and left behind. In that respect, you may be interested to know that many of our projects on show today make use of these latest technologies to develop solutions and new applications that solve real-world issues, improving our lives and the community around us. This afternoon, we are also very honored to have 2 guest speakers. Mr. Danny Tan, Head of Strategy, and Ms. Danny Lau, Head of Regional Purchasing and Environment, both from NEC Asia Pacific Private Limited, who will share with us about the future of digital sustainability. Incidentally, NEC is one of our key industry partners with whom we have set up an AI-driven Smart Command Center and Living Laboratory known as the TP NEC Living Lab, located in our new Integrative Built Environment Center, which we launched in January this year. The center is a fine example of the fruits of collaboration with our partners. We will continue to work with our industry partners to explore avenues for collaboration, knowledge sharing, and joint projects that would help to enrich our students' training, as well as to provide solutions for the industry. Should you have any ideas on how we can work together or explore any spin-off from the projects that you see today, do feel free to let us know. Once again, thank you, everyone, for taking the time to join us in our technology show. And may I wish you all an enriching time.
Thank you very much, Mr. Song, for your opening address. I'm sure our audience is looking forward to seeing the students' work and to share with you some examples of the exciting, innovative, and relevant work being done by the students of the School of Engineering in response to the real needs of our extended community and in collaboration with our industry partners.
Ladies and gentlemen, I'm currently at IBEC Center, and it's now my pleasure to introduce Mr. Danny Tan and Ms. Danny Lau, our industry speakers for today, both of whom have a wealth of experience in innovation and sustainability.
Mr. Tan is Head of Strategy at NEC Asia Pacific Private Limited, where he leads both businesses and digital transformation projects.
Ms. Lau is Regional Purchasing and Environment Manager also at NEC Asia Pacific Private Limited, who works with their affiliates in the APAC region towards achieving carbon neutrality and climate change objectives.
Today, they will share with us the future of digital sustainability in today's world and tell us how NEC is supporting important and timely solutions on a global scale. With a presentation entitled Digital Sustainability. Mr. Tan and Ms. Lau, please.
Good day, everybody. I'm Danny, the Regional Purchasing and Environment Manager in NEC.
Hi, everyone. I'm also Danny with a Y, Head of Strategy in NEC. Thank you for having both of us here today at the Engineering Tech Show. We understand today's session will be most helpful to you if we were to share our perspectives on how industry players like us are tackling sustainability challenges, but we would also like to share a little bit more about our academic to work-life journey, so that will be most helpful for you as you envision your future career path. So let's get started, Danny. Could you just share a little bit more about what the term digital sustainability actually means, and about how it actually impacts the society today?
Okay, to me, digital sustainability is simply about creating a sustainable society using the technologies available without leaving anybody behind. We often ask how we harness the tools of digital transformation to achieve our sustainability goals. With our government announcing Green Plan 2030, digital sustainability will be driving disruption, innovation, and global partnership, and creating many fun job opportunities for us.
In Singapore, we simplified this global concept by using this term called Society 5.0. Society 5.0 realizes a high degree of coming together between the cyberspace and physical space. The general rule is to utilize all the information we've gathered from both humans and machines, have it examined, and channel the results gained through AI and outside the abilities of humans back to the humans for their own benefit. Here's a quick video that showcases how NEC is leading meaningful digital sustainability projects around the world. I hope this gives you a quick idea of how we see digital sustainability.
Poverty, hunger, lack of access to health care. Many global social issues are waiting to be solved. NEC is forming strong bonds and partnerships to overcome issues that can't be solved through technology alone. Across the world, the lives of millions of children can be saved through proper vaccination. 1 in 4 children under age 5, on average, are not registered in the world today. And even when they are, they may not have proof of registration. To address this issue, NEC is working with Gavi and Simprints to deploy the world's first scalable fingerprint identification solution for children. This will ensure fair distribution of vaccines and easy management of vaccination records. In the Indian spice industry, the lack of transparent monitoring in the value chain has been a challenge in ensuring quality and traceability. Small farm owners are not receiving adequate profits due to the lack of direct market linkage. NEC is collaborating with the UNDP Accelerator Lab India to test the concept of spice traceability and trading platform empowered by blockchain technology. The project is expected to ensure better quality assurance, promote exports, and provide stable income to farmers. In 2020, 811 million people were undernourished. That's 1 in 10 people worldwide. With hunger on the rise, WFP is delivering more life-saving, life-changing support than ever before. NEC and WFP are exploring the use of advanced technologies to get more safe food to more people more quickly. In addition, a hybrid storage system registered with the Sustainable Technology Promotion Platform of Unido ITPO Tokyo, can reduce diesel fuel consumption by up to 80%, thereby reducing carbon dioxide emissions and ultimately helping to solve climate change. In cooperation with UN Habitat and Peace Winds Japan, we are supporting the Kalobeye settlement. Our goal is to promote economic independence and social integration between refugees and local residents. As part of the partnership with the International Committee of the Red Cross, we are looking to use AI to help identify areas where landmines are likely to be. Quicker, more accurate searches means mines can be cleared faster and land returned to use sooner. A world where no one is left behind. This is the world that NEC envisions. Together, we can shape the world towards a shared and beautiful future.
Orchestrating a brighter world. NEC.
All right, I hope you enjoyed the video. So Danny, could you share a little bit more about your role in NEC and how did it come about?
Okay, like you, I studied engineering in school. I think many of you have chosen engineering because it's very flexible. And you're right, because engineering work, engineers are actually very great at tech salesmen and also very good entrepreneurs. The engineering skill set that is hardwired in us is actually very useful because we find the problem, we find the solution, we iterate until we resolve the problem. And this is a very relevant skill set across industries and departments. So personally for me, I moved from supplier quality engineering to new product introduction, supply chain management, environment and sustainability management, all quite seamlessly and learning many new things along the way. So this engineering skill set that you hold is in demand anywhere and anytime. So for example, I find my work as the regional purchasing and environment manager very productive because NEC practice sustainable procurement. Corporations are required to emphasize sustainability throughout the entire global supply chain and be responsible for the activities when conducting business. And they need to reduce the impacts that they have on the environment as well as the society. So we require our suppliers to implement responsible business conduct in 6 priority key areas, which are human rights, occupational health and safety, fair trade, environment, information security, and product quality and safety. I'm very happy working in NEC because I'm very passionate about sustainability and so is NEC.
Right. Thanks, Danny. So I was a TP school student back in the early 2000s. This was right after the dot-com bust. Then IT and engineering were not a sought-after field of study. However, I could not imagine a future without technology and engineering, hence I pursued regardless of the market situation. After TP, I joined SMU, and then I pursued a master's in computer science over in Carnegie Mellon in Pittsburgh, USA. So I started my career working on cloud technologies in a telco, and as digitalization took shape across all industries, I was given the opportunity to join Temasek Holdings to lead the innovation and technology transformation for the upcoming Mandai Nature Precinct. So my time at Mandai really opened up my eyes in the fields of digital sustainability. And I think everyone who has not taken a chance to visit the zoo should do so in the near future. So I really discovered the joy in helping businesses transform, not just digitally, but fundamentally. At NEC, a company with more than 100 years of technology legacy is also looking ahead into 2030 and asking critical questions about its own business, how it's contributing to society. And this led me to my current role as Head of Strategy in NEC, where I work closely with a very talented group of friends and colleagues to make a difference in our work towards society.
Yeah, I would say that it's rare to find a job where our individual goals are aligned with the company's. So we want to create a livable, decarbonized society, an equal society where everybody lives and works to achieve your fullest potential. There is huge demand for engineering talent who can design this sustainable society where physical places are intertwined with digital technology. This is the purpose of the launch of the TP NEC Living Laboratory. Minister Maliki Osman, Second Minister for Education, said that he was impressed by the wide range of integrated technology available at the TP NEC Living Laboratory. It is a facility developed by Temasek Polytechnic in collaboration with NEC. At the lab, we would like to experiment with TP students on helping our world connect the dots between the various touch points of their lives. Here's a video of some cutting-edge technology alongside other multidisciplinary learning in areas such as architecture, design, engineering, IT, and environmental sustainability.
Orchestrating a Brighter World, NEC.
In conclusion, in a world full of disruption, innovation, and globalization, there is a wide ranging of opportunities for our youth to think about innovating, creating, and creating for change. I encourage you to be bold and have the confidence to chart your own destiny based on your own set of values. Your purposeful pursuit will land you in a very sweet spot. I wish to share this last thought. Ultimately, we must remember that you got here. What got you here won't get you there. And we must continuously learn, unlearn, and relearn to stay relevant in today's economic environment.
Yes, and I would just like to shout out to the female engineers out there. Be courageous in your meekness and spread your wings and soar in the engineering field, because women are wired to multitask, very resilient, and help bring together a very good value proposition. So I hope to see you all, ladies and gentlemen, in NEC, flaunting your boldness and confidence to chart your own decarbonized society and destiny with us. Thank you so much.
Thank you, everyone. See you soon.
Thank you.
Thank you very much, Mr. Tan and Ms. Lau, for sharing with us these fascinating insights.
I'm sure we all are looking forward to even more innovation from NEC in the future. But right now, it's time to talk about the projects from our own students.
Despite the lack of in-person events in 2021, our engineering students performed extremely well in a range of engineering competitions, winning several awards, including the Industrial Innovation Challenge, Gold Award,
and prizes in several other national and international level competitions.
We will be showcasing a number of these award-winning projects at today's event, as well as some of our outstanding major projects. Let's take a look at some of our competition winners.
There's been a pretty impressive performance from some of our students this year.
That's right, but that was only a taste of the variety of projects that we will be able to showcase this afternoon.
To kick off the project presentations, let's take a look at the Sustainable Built Environment Cluster by watching a short video about the brand new interactive Built Environment Center.
An all-encompassing centre that supports Singapore's push for the adoption of digitalisation and sustainability in built environment, IBEC serves as an important component of the sector's ecosystem. From digital architecture, intelligent building and facility management systems, students get to work with smart building technologies within an authentic environment to enhance their skills and knowledge. IBEC also collaborates with partners on industry-relevant curriculum, internships, as well as R&D projects to address the ever-changing demands of the sector. At TP, we are committed to creating a smarter and more sustainable built environment for all.
Wow, that was quite inspiring. Hey Nadira, have you ever had the chance to work on energy efficient buildings or on practicals like workplace safety?
Nope, but I'm excited for the opportunity to do so. In fact, I'm looking forward for my own major projects and industrial attachment in year 3.
Well, let's find out from the students in the next 2 project groups on how they have applied their knowledge and skills from their diploma to enhance sustainable built environments. Let's join the students as they showcase their presentations. Over to you.
Hi. Long time no see. So Fiona, what have you been doing lately?
So I was just looking at this article from Channel News Asia. Do you know a construction worker died after falling from a ladder, and the ladder was only 1.7 meters?
What? That's so dangerous.
Yep. This is why I've been training using the VWST training program so that I'm more educated about workplace safety. Let me show you this video.
Regulation 2112 of the WSH General Provisions Regulations requires that a lifting machine, which includes MEWP, shall be operated only by trained and competent person. In addition to the MEWP training course, an operator of a MEWP shall be familiarized with the controls and characteristics of each model of MEWP he is required to operate. Lifeline is shorter in length, restricts workers until a certain length to prevent them from falling into open sites.
Well, this program enables workers to visualize the hazards in a 3D environment so that they can safely identify hazards, assess risk, and also implement preventive measures before commencing work. This will help them create a safety mindset before they actually enter the physical work site, and also reduce the risk of workplace injury.
So when can I attend this training? I'm quite busy lately. Plus, I'll be traveling to Japan soon.
Well, this program can be done anytime or any day, even when you're in Japan.
So speaking of Japan, do you know that Liangkok was known for catering largely to Japanese community in Singapore, which was demolished last year. So for our project, we collaborate with another group on International Building Design Competition, which was organized by the Building and Construction Authority. So our key objective is to generate the concept design of a mixed-use building, which links up to Japan and incorporate local culture through a detailed site analysis. So the former Liangkok was chosen because it is located in the central business district and has easy accessibility such as having MRT and bus stops. So some highlight features of the building include ramp for visual and connectivity purposes. Furthermore, we also perform simulations such as computational, fluid dynamics, CFD, and solar, etc. to optimize the building design.
We actually went down to the BIM studio located at the recently launched Integrative Built Environment Center for our design and modeling process. We also went down to the BIM studio to help us predict and analyze our proposed designs to figure out which of them have the best energy efficiency and the best indoor environmental quality performance. Speaking of which, have you guys used an AR/VR headset before?
Yes, we have.
Well, for me, it's actually my first time when we went down to the BIM studio to use the digital tools provided there to help us visualize our model virtually. For example, there's a software called Enscape, which helps us to render buildings. So we used it to render our finished building, and we could have a close-up look of any room, for example, the bedroom. So it would generate a rendering so we can see what it will look like in the future. Would you guys like to have a look of the overall building?
Sure.
Thank you, team, for sharing your projects. Let's move on to the Q&A segment. Is there anyone who would like to ask any question?
Oh, we have a question from the live audience.
Okay, so let's head over to the LT now.
Why do we need this virtual training when it is also possible to learn at the worksite?
So actually the key benefits of this project would be the reduced injuries, as some of the workers may not be well trained enough and may be at risk of injuring themselves while undergoing training. So it allows workers to train in their own dorms, which is at a lower risk. So the next benefit is easily accessible also, and because of COVID, it will be better to train at home because of the situation also.
Oh look, there's someone else is trying to ask a question.
Can someone please pass him the mic?
Which platform software is used to collaborate between two groups and how?
We used a common data environment to facilitate project collaboration between both groups. So for the central model, we used Google Drive so that it is a main model that is accessible by all members of the team. As for the individual models, everyone has their own copy saved into their own hard drives where they can access at any time and edit whenever they need to. And then they will transfer the edits into the central model after they're done.
Thanks guys for your wonderful insights. I am definitely impressed. Although it seems like a great deal of hard work, they got to use their problem solving and team collaboration to really make it successful.
I agree. Well done, guys. Now, let us view a short video which will introduce the other sustainable built environment projects in this cluster. Moving on to our healthcare segment, let's have a quick virtual tour of the Healthcare Engineering Center in this video.
Our Healthcare Engineering Center brings together both scientists and engineers to advance the development of healthcare devices and systems based on biomedical micro-electromechanical systems, or BioMs for short. The center also works with various industry and academia partners to develop and deploy innovative devices for the medical and healthcare sectors.
By the way, Nadira, speaking of medical technology and equipment, have you ever had an MRI scan?
MRI scan? What is it? Is it a scary experience?
MRI stands for magnetic resonance imaging, and it could somewhat be a traumatic experience for some people.
Well, I understand that the two feature healthcare projects are firstly, a solution for MRI patient training, and secondly, the design of an affordable patient-specific prosthetic arm which allows objects to be carried and the applied force to be detected.
I see. The students are standing by to present their projects. Let's check them out.
Hey guys.
Hello.
Hello. Okay, guys, so I heard that you did an MRI simulation for your major project. So actually, my grandfather is actually getting an MRI, but he's claustrophobic, so he's terrified of tight spaces. How does your simulation actually work?
About that, so these are some of the issues that are brought up by CGH in relation to MRI. So due to these issues, it will lead to frequent cancellations of an MRI scan. And this would lead to a wastage of resources and time. So in order to help alleviate this issue, we have created this project which will help assess the patient's suitability for an MRI scan, without them needing to actually go for an actual MRI scan.
So the project is actually split into two subsystems, the hardware subsystem and also the software subsystems. The hardware subsystem consists of hardware sensors, VR, and also a pressure mat or pressure vest, which will be used to collect data for the patient during a mock examination. So as for the software subsystem, it consists of the administrator portal, the management console, and also the anomaly detection program, which will be used to evaluate whether the patient is suitable for an actual MRI scan.
Some of the devices that we use were the oximeter and the smart ring, which are used to measure the patient's heart rate and oxygen rate. These are then collected and sent to our Raspberry Pi for further analysis. Moreover, we also use our smart mat and our pressure vest, which are fitted with piezo sensors to capture the patient's movement when they are wearing the vest or when they are lying on the mat.
So this is a screenshot of the console application. So this application will retrieve data from the hardware sensors mentioned earlier and will display it here. So there are other features to this application, such as allowing the doctors to control the VR scenarios, and also allowing them to start or stop the movement detection algorithm, which will detect any movement in the patients. At the end of the exam, all this data collected will be uploaded onto the cloud. And finally, this is the administration portal page. So this is to be used by the doctors to help view the data of the patients and to assess if they are suitable or not for the exam. Additional features are that doctors can help patients book their exam or adjust the hardware sensors if they need to.
Oh, wow, yeah, your project sounds amazing and sounds really complex as well. So with all these complexities, how much does the project actually cost?
So actually the hardware costs about $100 to get the Raspberry Pi and also the hardware sensors. You know, why don't we actually look at the video that we took? So as you can see, we were actually in a hospital setting. And speaking of hospitals, I heard that you actually created a prosthetic arm for amputees. And so what about it?
Okay, so actually our prosthetic arms, right, are actually a lot different from the traditional ones. So traditional ones are actually just checking your electrical signals from your muscles. And then from there, it actually gets past a certain threshold. So it either opens or closes your hand. For our prosthetic arms itself, it's a bit more different from that. Basically, it's after it checks your signal, it doesn't just wait. It just keeps checking consistently, which makes it into a closed loop feedback. Afterwards, it actually gives us something like a sensory feedback or like haptic feedback. So it lets the user regain control of their life so that they're able to feel physical touch.
So speaking of sensory feedback, there are actually 5 main types of sensory feedback. So the main one we are using is actually force feedback, which is the most applicable for our use case. So what is force feedback, you may ask actually? Force feedback is when the user actually applies a force onto the object when they are grabbing on the object. So when they are grabbing onto it, their fingertips exert a force onto the object, and therefore this force will be translated to the user's arm to allow him to feel the amount of pressure. So in order for us to detect the amount of pressure that is being applied onto the object, we use force sensors. They'll be placed onto the fingertips, which is the most sensitive part in our hand. So with this force sensor that is being placed on the fingertip, when the user grabs onto the object, the microcontroller will be able to detect the amount of pressure that's being applied onto the object, therefore translating it to the user's arm and allowing him to feel the amount of pressure being applied to the object. So now let us watch a short video of our grip.
it actually look really cool, especially when you're scanning the hand. So what other reason makes your arm actually stand out more than the arms that are created outside?
So conventional prosthetic arm costs around $10,000 to $20,000 to create and actually sell in the market. So whereas ours is fully 3D printed and it only costs a few $100s to create. So besides that, our prosthetic arm is also fully customizable to allow the user to fit their arm more nicely. Besides that, with the 3D printing technology, the fingers are able to be replaced quickly and also be more durable throughout the long term.
Okay, I think we're actually out of time. Let's pass it back to the MC.
Thank you so much for sharing your individual projects. Let's head over to the Q&A session now. Alicia, do you have any questions from our friends online?
Oh, there's one question. This question is being directed to our friends who have been working on the prosthetic arm. The question is, if you were to be given more time and budget to work on this arm, what is one thing which you think you can improve on?
Okay, so for me personally, one thing I would have improved for my project if I had more time and budget would definitely have to be the PCB itself. So we want to make the PCB, the electronics inside, much more compact so that we save space, save money, and it just looks a lot neater and cleaner overall. And another thing that I would actually improve on is actually the EMG sensors. So right now, because we're actually measuring a large muscle group, I would actually want to simplify it and actually make it more complex at the same time by putting more sensors on different muscle groups so we can control the fingers individually. So that's what I would do if I had more time and budget.
Not forgetting our friends from the LT, there's a lady who is trying to ask a question.
I see. Can someone please pass her a mic? Thank you.
What are the main difficulties that you face during this project?
This seems like a very generic question.
That's true. Since the previous question has already been answered by the other team, may we please direct this question to the MRI project team?
Well, one main difficulty that we faced was the integration of the off-the-shelf sensors into our hardware ecosystem. Like for example, our oximeter, which we use to capture our heart rate for our patient, we can only successfully extract the values from some brands, as most brands did not include their API for their wireless or Bluetooth devices.
In addition, the collation of data on the software subsystem is not very straightforward, as there is a lot of information being gathered during one exam instance. Additionally, developing a useful data visualization platform where the clinicians are able to clearly visualize either a single exam instance or multiple exam instances is very difficult as well, especially since the visualization aspect is the most appropriate for displaying anomalies in the data.
Thanks guys for your answers.
Wow, these two projects are amazing.
Yes, I agree. Just knowing about the patient training simulation that the group has developed really makes me feel a lot more confident about undergoing such a beneficial medical procedure. Thank you guys so much for your practical solution.
Now let's take a quick look at some of the other healthcare projects in this cluster.
You guys have some really cool facilities. I had no idea that the students in the healthcare diploma did all that.
We now move on to the aviation and aerospace segment of today's program. In the aerospace-related diplomas, we cover all aspects of aviation, from engineering and electronics all the way to the business side of the industry.
There are some fantastic projects from the aviation and aerospace related diplomas, and the students are doing some really interesting work.
Our Aviation Research Center focuses on research and innovation to help develop cutting-edge aerospace capabilities that are future-oriented. Complete with fully equipped labs and a Civil Aviation Authority of Singapore SAR 147 certified hangar, the center also works closely with various industry partners on spearheading exploration into the possible evolution of unmanned aerial systems, instrumentation, and maintenance.
Alicia, what if I told you that drones can be programmed to fly themselves? The first group has actually developed a program that creates a safe corridor for a drone to navigate autonomously through the city, allowing it to reach emergency sites more quickly than any road vehicles.
Sounds interesting. Let's take a look at two important projects the groups have been working on. Over to you guys.
Yeah, I haven't seen you in a long time.
Yes, same to you.
So I heard that you're doing this very interesting VR project.
Yes, so our major project is regarding the VR systems. At the start, we had a lot of issues and problems as we did not know how to work with VR. After a while, throughout the process, we learned how to program different scenarios and finished up our project on time. How about you guys?
So actually, we faced the same issue. We had a lot of difficulties in the beginning. And I think we faced many ups and downs throughout the whole project. But overall, I think we managed to achieve our project's objective. And in the end, our project was quite successful. So actually, our industry partner is with Aspire. And the challenge of this is to create innovative improvements in the urban mobility area for urban mobility aerial vehicles, or UMAVs. So the aim of this is to create breakthroughs in the aeronautical space. So my team and I have decided to focus on a solution, which is to allow these drones to fly within Singapore safely. So here are our project objectives. So firstly, is to investigate on how these drones are able to operate in Singapore even with the strict laws in place. We have to be familiar with the drone laws in place so that our project will be successful. So secondly, is after researching on all these rules and regulations, we have to come up with a design, a concept, such that our drones will be able to fly in the sky. So we've come up with the concept of a drone corridor. So this drone corridor will help with our last objective, which is to aid emergency vehicles and by providing surveillance information to first responders. As these drones, with the help of drone corridors, will be able to fly to the emergency site quickly, faster than normal road vehicles, as they are able to avoid road congestions.
All right, so what exactly is a safe corridor? A safe corridor mainly has three main functions. So firstly, it acts as an airway for drones. This is similar to roads, but in the sky. Also, it helps to allow drones and people to coexist in the same urban environment without any harm to it. And also secondly, it allows drones to move from one point A to point B without any obstacles in its way. However, for this to happen, we also need inbuilt features such as object avoidance programming in the drone itself. And also thirdly, people, trees, or even buildings are just examples of objects in the urban environment. But however, we also need this safe corridor so that we can have our drones to fly without any harm to it and also autonomously.
So to meet our objectives, we basically have 5 main functions in our drones. So for the first one is object avoidance. So our drone will be able to detect an object and recognize it, and then it will be able to move in a certain way to avoid that object. So secondly, we have destination input, which is our drone has pre-programmed routes, and with the push of a button, the drone will fly to its destination. Thirdly, we have face tracking. So face tracking, the drone camera is able to recognize a person's face, and it will be able to track it, avoid it, or to follow it as well. So fourthly, we have a QR code.
So QR codes are pasted around the city, and when a drone scans it, it will be able to get information from the QR code on maybe like its position or the obstacles that are coming up. And lastly, we have line following, which is the drone is programmed to follow lines such as the lines that you find on the road, and this can be used for the drone to get to its destination when the destination is not in one of its pre-programmed routes. In conclusion, our drone is able to be implemented into an urban environment such as Singapore as autonomous UMAVs, and this can assist in emergencies, as this can, like Nicole said, can get to the site faster than a ground vehicle.
And also one idea that we have that we can implement into our drone is to have VR to help our emergency responders during first aid.
So I heard that you guys were doing VR, right? So maybe you can tell us more about it?
Yes, I agree that VR is very helpful for your project as well, as in your project sense, we can use VR for surveillance. So in case of your drone having any issues, we are able to deploy an off-site operator to help control the aircraft from inside of a VR scenario. Also, the VR will be able to help out in case of any first aid, for example, giving instructions to any bystanders, or if there are not yet any emergency responders on the site. So regarding that, for our project, we are using it as a training tool to help students. So our objectives are to create an immersive trainer for students to aid in the startup of a Boeing 777 aircraft. So the program that we used is Unity, the one that we use to make games. We also use the Oculus Rift S, and for the 3D models, we use 3ds Max. All of this combined together will help to create a more immersive experience for the user and help with all the real-life inputs in regards to the virtual space.
So moving on to our project design, we will task on creating the main menu, practice mode, and also a test mode. Our practice mode consists of a tutorial and guide system for the users to learn on the power-on procedures. And also, our program includes an interactable button with a retry option for when the user fails the test mode. Lastly, we also have a congratulations screen for when the user passes and successfully finishes the procedures.
So for the results, we have achieved an improved user experience, so greater amount of immersiveness for the user. Secondly, we learned a lot about the processes and the software that we had to use for this project. And throughout this whole project, we had a lot of feedbacks given by end users and our supervisors, and we had to work a lot on the feedback side of things.
So in conclusion, we feel that the users will get to experience a real-life simulation of the power-on procedure, which can also be easily accessed through our program. And moving on to the future work, we feel that this program will be passed on to the LTT team for further expansion and further progress.
So we'll now be watching a short video on our project.
Welcome to the B777 Maintenance Simulator Test Mode. Please perform the power on and power down procedure. You have made an error. Please re-attempt or practice again. Welcome to the B777 Maintenance Simulator. Practice mode will now begin. Please press on the battery button on the electrical panel. Please press on either, or both, of the primary and secondary external power buttons. Please push the electrical button on the EFES panel. Observe the lower ICAS display. To power down, ensure both primary and secondary external power is switched off. Turn off the battery button to complete power down procedure.
So I hope you enjoyed the presentation, and that is it from us.
Thanks guys for your presentations.
Wow, the thought of merging both drones and VR together, really very interesting.
Okay, relax Alicia. But right now, let's move on to our Q&A. It seems like we have a question from our YouTube channel.
This question is for the drone. So with regards to object recognition, we understand the drone is programmed to avoid stationary obstacles while on a defined flight path. However, how can we do so in the case of an obstacle that is moving?
That's some tough question there.
I think so too, but I'm excited to see how they can handle this question.
Alright, over to you guys.
Okay, so that's actually a very good question. So actually AI and machine learning is an upcoming technology. So we can use this and feed our drone with lots of new data and also make the drone learn on how the different movements of moving objects. And once it is more familiarized, it can learn to predict the data of the moving objects and also avoid it accordingly.
So yeah, actually we done this small scale version of it with our current drone, which is, as you can see, we showed it just now, the face tracking. So we input certain people's faces, and then it can detect anybody's faces actually, and it will just follow the faces accordingly. And this person moving is the undefined path that the person is walking. So the drone cannot expect how the person is moving, and it's still able to detect the person and avoid it or move away accordingly. So yeah, I think it's a possible thing with the help of AI and machine learning, like my friend mentioned just now.
However, the issues would be the processor and the reaction time of the drone. Because if we have a big processor with a fast reaction time, but the drone has a weight limit, and if the processor is too big, it cannot fly. But if also the processor is too small and the reaction time is not there, the object will already hit the drone by the time it recognizes the object. So we need to be able to find the perfect balance between the two for us to be able to avoid moving objects. Yeah.
Oh, it seems like we have another question coming from our friends online.
Oh, where is it?
There it is. The second question is, do you think virtual reality should simulate reality on every level?
Over to you guys.
Thank you for that interesting question. Before we think about this question, we have to think about how much our end product is trying to simulate reality. As our program has been programmed, we didn't actually do too much of realism, and without this much realism, the user was still able to reach a certain amount of immersiveness.
However, to improve immersiveness, we can include sensors such as like smell and touch. However, we have to be very careful as it can be disorienting for the user.
Thank you very much to these two project teams. I can see that these students are using the latest technology and gaining valuable skills in innovation design.
For sure. Before we end this segment, we have a video showcasing some of the other aviation and aerospace projects.
I can certainly see how relevant these are in the current aviation industry.
Let's move on to the fourth and final segment of our tech show today. A very broad definition of industrial automation and digitalization is the use of innovative technology to improve products, or processes.
In a nutshell, it is frequently described as Industry 4.0, the next industrial revolution.
Let's watch a video showcasing the TP Manufacturing Center at Temasek Polytechnic.
The Temasek Polytechnic Advanced Manufacturing Center concentrates on the need to upskill both the existing and future workforce as advanced manufacturing technologies such as robotics and automation, artificial intelligence, and the Internet of Things become more prevalent today. Students attached to the center get to do hands-on research and development on these emerging technologies, so that they are ready to ride the wave of the new Industry 4.0 transformation.
Wow, that is a very interesting video. And to add on, advanced manufacturing and digitalization can employ a diverse range of technologies, including AI, robotics, to name just a few.
Wow, I'm really curious to see how it can affect me as a consumer. Let us go to the 3 project groups right now to hear more about them.
Hi guys, how are you guys doing? Hey Kelly, good to see you took some time off TPAMC. Who are your friends here?
So on your left, we have Aaron and Jamil from Business Process and System Engineering. And on my right, we have Chong Wei and Kai from Electronics.
Hi guys. Yeah, so I'm Eldrick. I'm actually a student intern at TP's Advanced Manufacturing Center, where Kelly actually did her project. Yeah.
Wow, so what do you guys do there?
Okay, so you know we're moving towards Industry 4.0. So at TPMC, we do a lot of automation and digitalization, not only for the hardware, but for the software and services as well. Do you guys do a project on digitalization?
Yeah. Hi, Eldrick. Yeah, thanks for bringing that up. Actually, my group did a major project on incorporating RFID technology into IKEA Tampines workflow. So RFID technology is not something new. It has been around for decades, but it has only gained popularity in recent years when the cost of producing labels has gone down by a lot. So if you haven't gotten a clue on what radio frequency identification is, the main gist of it is radio waves are being picked up by antennas. So if you actually want to see it in real life, you can just head on to like Decathlon or Uniqlo. And if you notice that their self-checkout counters are actually automated. So with RFID technology, it has actually resulted in a very seamless user experience. So for our major project, which we call RATS, or RFID Article Tracking System, our main goal was to see how RFID technology could be used to increase the efficiency of a company's workflow by reducing the time it takes to conduct like a stock count while maintaining a high level of accuracy.
Yeah, and one of the challenges we actually faced during our project was which item do we even begin to use this RFID technology on? Because when we went to IKEA, it was a huge place, and we didn't know where to start. So we thought like the most reasonable way to conduct our experiment and our project was to tag the items that were going missing the most. And for us to even get started on like finding out which item was going missing the most, we had to scroll through and dig through thousands of rows of data. We had to do data analysis for like weeks actually. We had to clean the data, we had to organize the data, and finally visualize the data to even find out which items were going missing the most. And we highlighted 2 items among hundreds of items that were going missing the most. And we found out that this AA battery and also the resealable bags were going missing the most. And one thing that these items had in common was that they're loose items, meaning that if you actually go to IKEA, you'll find that these are packed in small boxes that could be easily misplaced or even stolen. So we tagged these items with the RFID tags, and then we designed an experiment, which we planned for it to last for like a couple of weeks, 3 weeks actually. But due to limited time, we only had the chance to do this for 3 days. So we actually had to go to IKEA for 3 a.m. in the morning. So half awake, we would do this experiment. We would tag the items. And then we designed this experiment. The one important part of this experiment was the blind count. So for the blind count is to eliminate any type of bias for our experiment. And what we would do is we would ask staff of IKEA to count the items manually before we even get there. And then we would have one of our team members to count it manually as well. And then we would use the device to use the RFID to do the stock count. With 3 days of data, we managed to find how much more accurate using RFID is, and how much less time we actually use to do the stock counting. I think from 8 minutes of doing manual counting, we managed to drop it to 1 minute, which is a whole lot less. So with the accuracy, actually, there's a lot of things that come into play when it comes to accuracy. The RFID tags may be damaged, or it could be missing, or it could be stolen. So we can't really meet 100% accuracy, but nevertheless, we managed to increase the accuracy a lot more than manual counting. But here's a short video that we made for our project.
Wow, who knew stock taking could be so interesting?
Yeah, who knew?
Hey, you guys from electronics, right? I see you guys doing a lot of projects in your labs. What do you actually do?
Yeah, so the project that we did is called the image detection system for the industrial transporters. So as you know, right, for modern day innovation comes with their own sets of problems, right? And one of the problems faced by this industrial transporter, right, is it colliding with the human obstacle. So this poses a safety concern. So the aim of our project is to assist this industrial transporter in navigating their pathing around the warehouses for detecting or to detect the obstacle detection. So for our obstacle detection system, it consists of Intel RealSense camera, which captures the images. These images are used to be analyzed by the OpenCV library. And actually data from the analyzed image are sent to the transporter using this OPCUA. Okay, and the whole program itself actually runs on this robotic operation system, or ROS in short. And the system that we are using is the Raspberry Pi 4. Okay, now I'll be moving on to my friend.
Okay, so I'm going to show you a video, which is about, the first part is about a omnidirectional low profile robot, which is used to check the underside of cars to check for illegal modifications. And the second part of the video is the demonstration of our obstacle detection system.
Hi, this is Tongye. This is our project, which is the imaging detection system for transporters. And this is our product. The Intel RealSense camera and Raspberry Pi 4 inside. And as I'm moving, so now the obstacle is detected. When I move up, there will be no detection. So our project also can detect the obstacle is a person or not. Alright.
So how these two systems work together is that since the robot is low profile, it cannot sense anything that's above it. So what we did is we introduced a separate detection system to help it sense or detect obstacles above it. So to help it avoid any collision. Also we enhance the algorithm by allowing it to recognize images. So in our case, we made it able to recognize humans. So you can see from the video, when my friend steps into the camera, you can see that the image there, it writes person. So it serves no additional purpose because it's still an obstacle detection, but it obviously will create more potential for future modifications.
And we also did not take much pictures of it. On the left side is our final prototype. On the right is part of the testing process of the black and white image. The white parts represent the parts that are detected. So you use it to like calculate to determine whether it's an obstacle. So throughout our project, at the start it was kind of tough because we had no prior knowledge to Ubuntu, ROS or OpenCV. So we had to do a lot of research on our own. But also we had some help from our supervisor, Mr. Yo. So big shout out to him. So overall, this is a quite long and tough journey, but also quite a rewarding one. Yeah.
Wow, the applications in your projects are very interesting. But can it be used for self-driving?
Yes, because in the first place, our project is meant to be used to help AGVs, which are automated guidance vehicles, to help them like navigate and avoid obstacles. So I think it will be suitable for any kind of automated or self-driving vehicles.
How about the guys from mechatronics? I heard you're working on some top secret project.
No lah. Rifki and I are working on a automatic condition monitoring system alongside with Eldrick. So introduction will be engineering industry runs on many machines, especially they will run it at least 24 hours throughout the entire week, 7 days. And any point of time, definitely there might be malfunction or wear and tear to particular critical equipment itself. And there won't be any additional manpower to go down on site at maybe like AM itself or midnight. So we decided to come out with a detection that can detect critical equipment while the machine is running. So our project objective is to develop and create a condition monitoring system, which is used for predictive maintenance. And alongside, we add on a vibration probe to the critical equipment such as bearing or motor and collect data and add into our dashboards. Project scope is to build a motor equipment, and then we wire and configure into an existing conditioning panel. Therefore, we develop into a conditioning monitoring dashboard where we can log data.
So some of the key technologies we use, we have a VFD or what we call variable frequency drive to control the motor. So we also have a Keyence PLC to control the speed of the motor to vary the frequency. Then the IFM edge controller, the orange color one, is where we actually attach the vibration sensor so that we can collect vibration and speed data. And then we also design one Keyence HMI for the user to start and stop the motor. So these are the key softwares that we use together with the key technologies as mentioned above. So let's take a look at a video demonstration.
So when we first started off, we have to rewire the motor and the control panel to add in the labels. And while assembling, we'll assemble the shaft, coupling, and 3D printed part and bearings together. So this is the 3D printed part of a propeller. And this is our first test run alongside with a simple programming. And due to safety feature itself, we decided to add on an acrylic frame. And this is the process. Then we went on to Aviva Edge to create the dashboard from scratch. And then we do a full run. This is a detection to collect data of the vibration. Then it will be displayed in this dashboard, real time. Operators will be able to be prompt when the vibration exceeds and it exceeds its speed limit. And this is the overview of the whole project.
Yeah, so moving forward, we want to do predictive maintenance. So our approach was to use supervised machine learning. So you can see we have many damaged bearings. We have cracked bearings, bearings with no grease, and rusty bearings. So using all these three data, we can actually feed it into a supervised machine learning model to do predictive maintenance in the future. Yeah. So for now, the key benefit is that we can display the real-time data to the user in charge. And we are also able to predict whether the part is going to be damaged while moving the probe around. So we don't need to put it at the bearing. We can put it on the motor, the shaft, things like that. So we also allow the user to be able to observe all this from a dashboard from somewhere else instead of going to the equipment to do the physical testing and checking. Yeah.
Well, guys, it has been a very fruitful sharing session. It has been nice to see hardware, software, and data systems coming together to improve the way things are being done. And it's all happening in TP.
Yeah. Thank you so much for your sharing. Now, let's move on to stock pick some questions.
I see what you did there.
Whoops.
Okay, so moving on, we have some questions from the audience online. So the first question is, why do you decide to use RFID technology to track the stock?
All right, to the viewers behind the screen. Okay, so there's two reasons. Okay, the first reason is that RFID technology, specifically UHF or ultra-high frequency RFID technology, can be scanned in batches, which is good because if there are many items, they can all be scanned in one go as compared to counting each of them one by one by one by one. And the second reason why RFID technology was used was that you do not need a direct line of sight, to actually read them. You know, unlike traditional barcode technology where you have to go and point your gun at the barcode before it gets detected, by RFID technology, your items or tags, right, they could actually be hidden or even behind layers of stuff, and you don't even have to actually see them before it gets picked up by the scanner. So that's why we chose RFID technology for our application. That's right.
Oh, there's a question from our friend in the LT. Can someone please pass him the mic? Thank you.
Why was Raspberry Pi microcontroller was chosen instead of Arduino or other controllers?
Yeah, so first of all, our program runs on ROS, which is only compatible on Ubuntu and is very commonly used on a Raspberry Pi. Also, it needs to be able to consume OpenCV libraries for machine learning and image processing. And to do that, you need a good processing power, and the Raspberry Pi has that. And also, speaking of processing power, it's also the most cost-effective amongst many or most other microcontrollers. Yeah.
Due to time constraints, we are taking our final question from our YouTube viewers.
So the question is, what is the difference between condition monitoring and predictive maintenance?
May we invite the condition monitoring system group to answer this question?
That is a very good question. So the key differences between the two is actually time. So condition monitoring is actually focusing more on time domain, real-time domain, and when the machines reach its limits, it will actually prompt a notification or alarm to alert the operators.
But for predictive maintenance, so it's actually in the name already, we're trying to predict when to maintain it as compared to waiting for a fault to happen, when an alarm to happen, then we maintain it. So what we do is we actually extract time domain and frequency domain features from the data, and then we feed it into a model to try to predict the lifespan of the machine. So once we know the lifespan, we can actually just maintain it maybe a few days before when it's predicted to break down. Yeah.
Alicia, I would like to ask you, which of these three projects impresses you the most?
I realize that they are all very important in delivering quality products at the most cost-efficient and effective price. But I just can't help it. I'm a big fan of IKEA.
I thought so too. So before we go on, we'd like to present a short video of some of the other projects in the industrial automation and digitalization cluster. That is absolutely fascinating.
Yes, it is an impressive example of adapting and innovating to remain competitive.
That's true. And these projects also demonstrates the strong links that we have with our industry partners.
Ladies and gentlemen, this concludes our program for this afternoon.
On behalf of Temasek Polytechnic and the School of Engineering, we would like to thank you once again for joining with us here today and for your participation in this event.
Please take a moment to scan the QR code to provide some important feedback on today's event. We encourage TP students and freshmen to complete this survey to claim your seal points.
Also, be sure to like this video on YouTube.
Please don't forget to give us a like and subscribe us.
Thank you for being with us and have a great day.